All right, so on to 36. And you've seen one like this before where we did a quotient rule having two functions. Now we're doing a product rule with two functions. So the important thing to realize is that h prime is going to be f times g prime, f times g prime plus f prime times g. And we're doing this at 3, so now let's kind of see here, let's think about what f of 3 is. F of 3, remember, is the y value of f at the x value 3. So here's f, and at 3, the y value of f is 3. Let's think now about f prime of 3. F prime is saying, what is the slope of f at 3? Well, the good news is f is a line, so the slope is the same anywhere, but specifically that slope is, find a nice crossing point like these two. The slope is up 1 over 3, positive 1/3. Now let's investigate g of 3. G of 3 means the y value on g at 3, and that y value is 1. And g prime of 3 is the slope of g, and again, g is a line, so its slope is the same everywhere, and that slope goes down to right 1, so the slope is negative 2. And so now we're going to plug that in to find h prime of 3. So f of 3 is 3, g prime of 3 is negative 2, f prime of 3 is 1/3, and g of 3 is 1. So when you work this out, we get negative 6 plus 1/3, which means we have negative 5 and 2/3. And if it's been a while since you've dealt with mixed numbers, you do 3 times 5 and then add the 2, so we have negative 17 over 3. However that shows up in your multiple choice answer choices. Up next, 37, we're investigating an infinite limit. Now remember, with infinite limits, we need to care about our highest growing or our fastest growing term in the numerator and denominator if we have a fractional infinite limit, which means the highest growing term or fastest growing term is that e to the 6x. Once you have an exponential function, any linear term like 2x, there's no square, it's just a number in an x, that's what we kind of call linear. That's going to go pretty slow by comparison to an exponential. So this is our highest degree term in the numerator. And in the denominator, there's only one term, so we have 3x here. Now, once we're investigating an infinite limit and only the highest degree terms matter, well, now let's look at this. We have ln and e meeting up again. When that happens, they usually cancel out. And now we have those canceling out. So we just have 2. So as x approaches infinity, we're going to be approaching 2. And the same would be true, let me see here, would the same be true if we were approaching negative infinity? It looks like it would be as well, because those double negatives would cancel out. So the important thing is to think about when you're doing infinite limits, and only when you're doing infinite limits can you throw this approximation symbol and drop those other terms. But the term that grows fastest is the only one that's going to matter. All right, up next, 38. I'll kind of give you a hint. On the exam, it's going to be different. In other words, you're going to have a function drawn, and you're going to have to figure out what is going on with that function. So you're kind of doing this one in reverse. You're making the graph that you're going to see because this is what the multiple choice answer says about the graph. So let's hear, draw a function who on an interval between a and b is increasing and continuous, and a point C where it changes from concave up to concave down. So what this is saying is there's a graph somewhere that exists from an x value a to an x value b, and it's increasing the whole time. So it has a starting point, I don't know, somewhere down here, and an ending point somewhere over here. It also says there's a point C in between. Now who knows, it could be in between or it could be way above or way below, but it says where it changes from being concave up to concave down. So that means C is an inflection point. And again, let's just draw a concave up segment from A to C. That probably looks something like this. All right, that's concave up. You can think about that being part of a quadratic. And now it's going to change to being concave down. Maybe it looks something like that. All right, and that's a concave down section. So we've correctly drawn the segment. Well, it should be increasing the whole time, so it shouldn't have that downward dip. So it's going to look something like that. Now it's increasing the whole time. It got a little sloppy, but you see the idea. Increasing, the slope is always positive, and it changes from looking concave up to concave down. So just remember that idea of what concavity looks like and what it means to be increasing. It means your slopes are always positive. Whenever you draw a tangent slope, it's always positive. All right, on to 39, we're almost done. Certain area. Now, one thing is, if you remember anything about 30, 60, 90 triangles, they do have kind of a formula to them. And we can also just remember the area formula for a triangle is 1/2 times base times height. Now, a 30, 60, 90 triangle looks, pretty much something like this. And so what they're saying is the smallest side is x. And so one thing we can kind of do is deconstruct this area formula because we will kind of need it in a second. So if this is x and this is the smallest side, and the area formula is 1/2 base or 1/2 x times something, and we got an area of essentially something over 2 times x times something else, then this must be root 3x. In other words, when you multiply all this together, you get the area formula. So this must be root 3x. And that will matter in a minute because we need the change of the hypotenuse. And spoiler alert, if you do the Pythagorean theorem with these two and solve for your missing side, c, you're going to end up getting 2x. All right, so that's super important. Now let's kind of get through this problem using our related rates information. So they tell us the value of dA dt. And so let's see here, dA dt. Let's derive that area formula now. Is going to end up being just root 3 because the 2 over 2 is going to cancel when you do the power rule, x dx dt. They tell us this area formula is 15 root 3. They also tell us that x is 9. So we need to solve for dx dt, and that means we're essentially going to have 15 over 9, which is 5 over 3. All right, so now I know what dx dt is, and we want to know what the rate of change is for the hypotenuse. Well, the hypotenuse is given by 2x, and so what that means is we just need, if h is 2x, then dh dt, well, when we derive this, it's just going to be 2 dx dt, and we have dx dt, so dh dt is 10 over 3. So definitely a hard problem, but I guess the important things here to deconstruct this is remember how 30, 60, 90 triangles are related. They do have this x root 3, 2x relationship. Sometimes we do divide the two and we get root 3 over 2 and x over 2, and that's where our unit circle values come from because unit circle values are on 30s and 60s and 90s. But, because they told us one part, 1/2 x, and we know what the total area formula is, we could deconstruct it and figure out this is root 3x and do the Pythagorean theorem to figure out this is 2x. From there, it might have seemed like we needed the Pythagorean theorem to do our related rates problem itself, but our related rates problem actually was fairly simple. The hard part was knowing where everything was on the triangle. So just a few more, and they are calculator allowed. So we're supposed to order the value of our derivatives from least to greatest. And I've kind of shown you all this problem before, but let's just say this. F prime of A is negative. So hopefully you can see that the tangent line would be negative. F prime of B is positive, and F prime of C is positive. But if we draw those tangent lines of B and C, we should be able to see that B is more positive than C. All right, so in other words, the tangent line for B looks something like this, and the tangent line of C looks something like that, so it's not going to be as positive. So I'm supposed to order these from least to greatest. Well, since A is negative, it's definitely the least. So F prime of A is less than, well, B is the most positive, so that means C should go next. So F prime of C is the next largest derivative, and F prime of B is therefore the largest, so that should be your answer. I guess one thing I would say in general, I haven't really discussed this, is as you go through your wonderful study guide, and as you actually go through the real exam, be careful to do work on your own before you look at the answer choices. Because I know when you see these written in kind of like, is it ACB, ABC, CBA, all that other stuff, it can get kind of confusing. But I think doing work on your own and ignoring the answer choices, then comparing yours with the answer choices through the whole exam is going to be very beneficial to you. So up next, we need to find out where a graph is concave down. Notice they gave us G prime, so we only need to derive it one more time. So we'll get 5x to the fourth minus 9x squared. And let's see here, we can take 2x, or x squared rather, out of that. We'll be left with 5x squared minus 3. Let's see here. So now we have x squared, and we have, this gets kind of ugly. Well, this is going to be x squared equals 3/5. So if we want to make a sign chart here, we've got 0 in the middle, and we're essentially going to have positive root 3/5 and negative root 3/5. And this is a calculator allowed question too, I forgot about that, but hopefully you can see that we can figure that out on our own as well. So we want to know where the graph is concave down. Now g double prime is a positive fourth degree polynomial. So if you think about anything even polynomial, it's going to end by having this U shape on the ends. So I know this is going to be positive, I know this is going to be positive. Since these are unique single roots, I know it's going to pass to below the x-axis. Because 0 is a double root, I know it's going to bounce off and remain negative, and then it's going to be positive afterwards. But let's look at the graph and confirm that. So after I calculated g double prime, which I would do, it's just a basic polynomial. I wouldn't rely on the calculator to graph the derivative. Whoops. Let me set my window back to standard, so number 6. And the root of 3/5 is going to be pretty close to, yeah, but we can see our answer right there. So it's positive to the left, it's negative pretty much everywhere until it gets to the other side, but it does bounce off that 0. All right, 2 more. We have a function whose derivative is given by that wacky thing, and we need to find where this function has a local max from -4 to 1. Remember, a local max is where the derivative crosses from above the x-axis to below the x-axis. Or in other words, where f prime changes from positive to negative. Because remember, visually, if a derivative is changing from positive to negative, it looks like that, and so you do have a local max somewhere. So let's rely on the calculator this time, since this is definitely ugly, to see where this happens. Make sure when you have a fraction derivative and there's multiple terms, you put that whole numerator in parentheses and the whole denominator in parentheses. Actually, in this case, our denominator doesn't necessarily need to be in parentheses since the whole denominator is in one single root, but it wouldn't hurt to put an extra set of parentheses in there. Anyway, so there's our derivative. Now notice it only wants this from -4 to 1, so I'm going to change my x window from -4 to 1, so I don't need to see anything else that would possibly confuse me. So where does this change from positive to negative? Right there. And that's it. So let's find that one point. Let's calculate that 0. The left of 0 is right there. The right of that 0 is right there. And so that means -1.389 is my answer. And now we're down to the last problem. So we have a twice differentiable function, and it says describe whether the function has a positive or negative slope, and whether the slope is increasing or decreasing from 1 to 9. Now, this question, the way I phrased it, and we've talked about counterexample graphs, you'll see when you get your multiple choice answers what's going on here. But let's just graph this. We can notice that our x values are changing constantly. There's always a unit of 2 in between them. So we have 1, 3, 5, 7, 9. They're evenly spaced apart. And we start at, let's see here, we'll just put -11 somewhere down here. Then it goes to -5. Then it goes to -1. Then it goes to +2. And then it goes to 3. And so if we look at this graph, it looks like for the general trend, I think, so like which could be true, and it does look like f prime is positive, but getting less positive. So in other words, f prime is positive, but decreasing in its positivity. And that's what we would say. So f prime, again, the derivative is positive, but it is decreasing in value. In other words, it looks like the slope right here is, I don't know, maybe 3. Now it looks like it's maybe 2. Now it looks like it's 1. Now maybe it looks like it's like 2/5. Now it looks like it's 1/4. You kind of get the idea that it is positive, but it's getting less positive. And with that, we finished the entire study guide.